Hello there, I'm Thomas Hatsios, German-American pilot flying the Boeing 787-900 tonight's flight. We're going to be overflying Zurich, Switzerland, Germany. They're coming back to Zurich International Airport, runway 1449, Lszh localizer, landing surround the cockpit for the pre-takeoff preparation of the quality wings, Boeing 787-900 in Microsoft Flight Simulator. I'll show you the cockpit facing the function of the Boeing 787-900 jet aircraft. I'm going to start with the primary flight display. The displays are the airspeed indicated, the airspeed selected from the autopilot and flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the barometric pressure of the outside atmosphere, the target altitude selected from the autopilot flight director system panel, the vertical rate of climb descent of the aircraft in tens, hundreds, and thousands feet per minute, the steepness of the trigonometric angles in the increase and can climb descent. We have also the artificial horizon with the attitude indicator, the pitch ladder decrease and the bank angle decrease, the Lszh localizer, the horizontal localizer that receives the radio frequency transmitted from the threshold antennas of the runways we're going to use for takeoff and for landing. So we have the Zurich International Airport, the Lszh and runway 14. Lszh localizer instrument landing system. We're going to use both for takeoff and for landing. You're going to see the horizontal localizer and the vertical glide slope on the Lszh localizer crossbars displayed in the primary flight display, and now the Lszh localizer frequency. So we have the onboard antennas that receive the radio frequency from the airport runway 14. So we're gonna have to be aligned also with the magnetic north pole heading 136 degrees for the runway 14. For the Lszh localizer heading. So we have also the flight director crossbus for manual guidance of the aircraft and the autopilot crossbus for automatic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies and the flight mode on zero with the autopilot and the auto throttle. Later on vertical navigation modes. We have also the ITZERLAND with the magnetic heading and track, the integrated standby. The integrated display of the flight plan. You're gonna see later we're gonna create a flight plan or a flight path route using the magnetic gonna be displayed in the HSI. Also in the navigation display, we have the navigation display that displays the horizontal and the vertical profile of the aircraft as it flies, and the flight plan, and also the terrain and weather reflections from the weather radar. You can see the terrain around you displayed with red, green, and yellow color. So you can see the terrain right now over here. You can see also the lakes, the rivers, the sea with blue color. So I'm gonna show you later better display of the navigation display of the horizontal and vertical profile, and also you can see the terrain map with the airports where they are located. So you can see our airport, the Zurich International Airport. We're gonna use both for takeoff and for landing. The 4-letter account name. Also we have the board stations, the ADS, the NDPs, the waypoints, which are horizontal vertical navigation fixes. You can see we're gonna use some waypoints using the flight management computer. I'm gonna input the flight plan and select some waypoints. Also you're gonna see that later. So I'm gonna show you all these things. You will see also we have the magnetic north pole and the geographic north pole and magnetic variation bending over around the world. We have the range in nautical miles. We have the wind direction and speed, the ground speed of the aircraft. You can see also other aircraft that fly around our own aircraft. You can see the distance they are located. The altitude difference from our aircraft, whether we are higher or lower, how many thousands feet or hundreds feet higher or lower they are from our aircraft, whether they climb or descend with respect to our aircraft, and also you can calculate using the TCASs, and you can calculate using the transporter, the DSP and ADC transmitter receiver that transmits our frequency to other aircraft and the air traffic control, and also receives from other aircraft and can calculate using its computers the other aircraft position, distance, and also the velocity between our aircraft and the other aircraft. It can give us a warning if we have an incoming collision. Using the TCASs and the traffic collision advisory system used in the primary flight display and the navigation display. So also we have other modes you're gonna see later. We have also the autopilot flight director system panel, the flight management computer, the flight controls, the thrust levers. So I will show you how to use all these systems over here. You can see the flight controls. I'm gonna use the side stick I have to control the yoke of the Boeing 787 for climb descent of making turns left and right. The rudder pedals. We have the nose wheel steering here, the tiller. We have the thrust levers also. You can see I'm using the thrust levers. You can see the thrust levers of the aircraft moving forward the raft, and you will see the change of the thrust commanded over here. The actual thrust, it takes like a few seconds for the engines to increase. You will see the warnings that were not configured for takeoff right now when I increase the thrust for takeoff. So you will see also other things inside the cockpit. You will see autopilot flight director system panel here. The selections we have. So we have autopilot engage, disengage, the airspeed select knob here, the LNAV, VNAV, flight level change, climb continuous, auto throttle, flight director, auto throttle left and right, heading and bank angle select, vertical rate of climb, descent and flight path angle, altitude select. Also here we have the barometric pressure setting. You will see in the display barometric setting in inches for mercury, hectopascals, baro radio, the plan and the rates, the display of the over here of the navigation display also, and also we have weather radar, traffic and terrain on the display. So you can see here the primary flight display, what it displays. Over here you can see the airspeed tape that we have, the airspeed indicated right now. 30 knots, the radio altitude above the ground, minus 2 feet. The pitch ladder 2.5, 5, 7.5, 10 feet. We here 12.5, 15, 17.5, 12, 20 degrees for pitch up or pitch down. Also the bank angle in degrees, how many degrees we make a bank roll in flight. Also this is the barometric altitude above the sea level, the barometric pressure over here set 29.92 inches of mercury, radio altitude. So you will see the barometric setting right now, 1430 feet barometric altitude for 29.92 inches of mercury. Also you can see the vertical rate of climb and descent of the aircraft, 10 hundreds and 1000 feet per minute. You'll see this needle moving not like 500, 1000, 1500, 2000 up or down when we climb or we descend. Also you can see the selections we have over here, the displays. You will see different a different layout after we're gonna set up the flight management computer. You will see a different display information, a little bit different. Now it's more general. So you can see no V speeds. We have not yet selected the takeoff speeds. Flight mode annunciator with the autopilot, auto throttle, radar and left navigation modes on takeoff ground, and the airspeed 200 knots, altitude 10,000 feet, and heading 360 degrees are all the same as the one selected here. 200 knots, 360 degrees, heading at 10,000 altitude. You can see both primary flight displays over here display the same information for the altitude, airspeed and heading. So we're gonna change this later. You will see how we're gonna use the flight management computer, input some data here. So you will see all these things. You will see also we have here the flight management computer. I'm gonna create a flight plan. You can see the keyboard, the data input display here, the control display unit, which is with the mouse also. I can use the mouse cursor here to select a different mode over here, the index perhaps, so you can see I can select either one. You will see the purple over here, the display that moves up and down. So have the mouse cursor, and I'll show you in a couple of minutes using this mouse pad here. So we have the thrust levers, also we have the horizontal trim stabilizer, the overhead panel over here. You will see the overhead panel, what it displays, the functions. We're gonna make an exit start demonstration before going into flight. I will show you all the systems. So you can see also here we have some functions like the horizontal trim stabilizer, the pitch trim. You will see in a couple of minutes. So you can see the outside view again. Maybe I will talk to you about how we're gonna set up the flight management computer. I will talk to you now about aerodynamics, about the Newton's physics and some principles we need to know for flying the aircraft. The principles of flying are also needed for the air transfer pilot license, some aerodynamics, aeronautical engineering, and physics. So Newton's physics underneath your fluids, you will see some also mathematical principles. So it's very simple. You can see here we have the aircraft. You can see the aircraft wings hold the weight of the aircraft as the aircraft will be flying using the aerodynamic lift over the surface area of the wings. You can see the mean aerodynamic chord position pretty much is 23% of the mean aerodynamic chord. It's where the maximum aerodynamic lift occurs in the forward wings. We'll have also the center of pressure. You can move back or forward as we fly, depending on the airspeed and the attitude of the aircraft. Also, over here is where the stall will begin in the mean aerodynamic chord position. All the way back, the airflow becomes detached as we fly for a given angle of attack and an airspeed that is changing. It can increase or decrease. So we have also the center of gravity of the aircraft is calculated pretty much around here, where is the mean aerodynamic chord as we fly. We can see we have the thrust vectors from the engines, the thrust propulsion from the jet engines or jet engines blast, as you can see, that moves the aircraft forward. We have also some axes, as I told you, the vertical axis, which is also the yawing axis. We can use the rudder over here to move the aircraft around the vertical axis. Is the yawing axis. You can make turns to the left or to the right, like this, using the rudder pedals over here. So the rudder pedals here are left and right. As you can see, rudder pedals left and right, both sides move together, the rudder pedals. So this makes the vertical tail to move around the rudder pedals. So this is the yawing axis. We have also the elevator, the pitch axis. So the elevator is here, as you can see, this column is the elevator for climb and descent. Very simple. So this is the pitch axis or lateral axis from wingtip to wingtip over here. From the one wingtip to the other, transverses also the center of gravity. You can make the aircraft pitch up or pitch down. We have also the horizontal trim stabilizer as we fly. So you can descend, you can climb. Make turns in the flight. And also make turns around the longitudinal axis, as you can see. This is the longitudinal axis of the aircraft. The transverse again at the center of gravity, so you make the roll around the longitudinal axis using the roll spoilers, ailerons and flaperons. So this is the roll. You can use all together, all flight controls together, having the deflections from the flight control. So this is the roll axis over here. Make left and right turn using the flight controls. So it's very simple. You can see relaxes. So you can see, as I'm telling you about the Newton's physics and aerodynamics of the aircraft. We have also the wings of the aircraft. When we fly with the thrust from the engines, the thrust vectors to move forward the aircraft, we have the flow of air. So you can see the bottom surface of the wings is more flat. Also we have now the flaps extended, and when we fly we might have an angle of attack like this, a positive angle of attack, so the airflow will be moving slower below the wings using the nuclear fluid, so we're going to be having higher pressure, which pressurizes the aircraft's wings and weight up into the air. So also you can see the top surface of the wings here is more curved, so using the Bernoulli theory of fluids, the airflow is moving much faster above the wings. So we have lower pressure above the wings, which sucks the aircraft weight up into the air with the wings, of course. So this is the basic principles you need to know about aerodynamics and the forces of flight. We have the lift from the wings. This is what generates the lift, the differential pressure, higher pressure below the wings and lower pressure above the wings. It makes the aircraft weight up into the air. So we have again, as I told you, the stall speed. You can see the stall over here as we fly using the mirror dynamic chord position. You have the airspeed and the stall speed. We're gonna talk later. We have to monitor here with a red and yellow indication. You will see the stall speed when we get the flying. So we have a few more minutes for this flight. I will show you a little bit more of the flight controls now. Besides the camera using the Lszh Extreme 3D for controlling the elevator for climbing the descent, also the ailerons and the spoilers for making bunkers left and right. There are other pedals for yawing turns, also for nose wheel steering. In the ground we have the nose wheel of the aircraft is controlled also by the rudder pedals. Also we have the toe brakes. So you can see how many functions we have. We have the horizontal trim stabilizer. Also have the thrust levers in my side stick, the Lszh Extreme 3D over here. So you can see we can climb, you can descend. Over here you can make turns left and right. Also the thrust levers, the horizontal trim stabilizer. I'm gonna show you the function of the horizontal trim stabilizer later. So this is the control column of the yoke of the Boeing 787 for controlling the elevator climb and descent. This is the control wheel to make turns right, left. Also the rudder pedals, as I show you, the tiller, the flaps and the slots here. I will show you later with the horizontal trim stabilizer. Also we can see again the outside view over here for the flight controls, making turns. So you can see both the captain and the first officer flight controls move together. They're connected in flight. They don't move independently from south like in the Airbus, where you have the seismic priority unless you have a failure in the system in flight. So all together, all flight controls, you can use them together to have coordinated flight controls. Also you can see maybe this side. I'm gonna show you one more side of the outside view again. So you can see again we can climb and we can descend like this. Make turns to the left, make turns to the right. Quite simple. So make turns to the right, turns to the left, rudder pedals. Also nose wheel steering, thrust levers over here. We have the thrust levers, as you can see. You can see the thrust over here. The thrust levers moving forward or aft like this. We have the thrust lever here function. Very easy, quite simple. Also the flight controls, as you can see. So hope you like the side stick I'm using. It's also for the Airbuses, both. You can use it for the Boeing here to control. We have the same output of flight control. So climb, descent, make turns left and right. The horizontal trim stabilizer, the thrust levers over here, and also the outside view. So making turns, right, left, climb, so this is all the flight controls. Also ailerons and spoilers like this again. So this is all the functions of the Boeing 787 flight controls. I will show you a few more things in more detail. Over here, like I'm gonna show you now the horizontal trim stabilizer. When you fly, you can trim the horizontal tail of the aircraft to relieve the air pressures from the flight controls from the yoke. Also to balance the aircraft in flight. So you have both manual and automatic. You have auto trim function also. So you can use horizontal trim stabilizer over here of the horizontal tail. You have this control, as you can see. So you can see horizontal trim elevator trim up. This way is trimming up, this way is trimming down the aircraft horizontal tail. So this is what you do when you press this switch. Is over here. You press this switch over here, which brings the horizontal tail of the aircraft up and down, as you can see. So you can trim elevator trim, as you can see. This way is nose up. You trim the elevator to pitch up the nose of the aircraft, and this way you trim the elevator to pitch down the nose of the aircraft. You have also the head-up declutter. You have the autopilot disconnect here. You press and you disconnect the autopilot. We have also the auto trim system of the Boeing 787 from the autopilot flight director system panel, the auto throttle, also the flight controls computers of the Boeing 787. This is a fly-by-wire aircraft, so it has the flight control computers to control the flight controls using the normal, the alternating, and the direct low of the aircraft, like in the Airbus. So we have the channels of the flight control computers. We have the manual control of the horizontal trim stabilizer here, this switch. So when you fly, you trim up and down the whole tail or just the elevator. This aircraft is just the elevator. So we have the flight control computers here, as you can see. primary flight control computers in the auto position. So you trim the horizontal tail. Also you have the auto trim function over here. So the auto trim means it can trim itself automatically. We have here, if you have a failure that affects the hydraulic systems over here, the control that acts with horizontal stabilizers, you're gonna have a malfunction of the auto trim system. So you come down here, and this is for all Boeing 737, 747, 757, 767, 777, Boeing 787. You open from normal to cut off the stub trim L2 and R2, from normal to cut off, as you can see. Then you use only the alternate pit trim, the manual trim. Trim the nose up and trim the nose down as you fly, or just the manual. So we have also the parking brakes here, not related, but we have to show them now. So you use only the manual trim after over here. So we have other functions also here. You can see the engines, the thrust levers, the auto throttle, disconnect switch here, the takeoff go around switch over here, the thrust reverse, pull up and reverse the flow gear, the fuel control left and right for the engines, the left and right, the cutoff also, the flaps I will show you now, the fire extinguishers left and right, engine pull out and switch and turn, the transporter, radio management panel and navigation radios, also the rudder trim. So you can see what it can tune here, for instance, a few of the functions of the aircraft. We have also here the flaps I forgot to mention, so you can use the flaps how many degrees you like them. So you set the flaps, for instance, all the way up. You will see it moves all the way up, and then all the way down. You will see how many degrees you want them. 35, 20, 18, 17, 15, 10. So you see the transition of the flaps over here, how many degrees you set them, so you can retract. You see 15 up now. You can extend like 10, 15, 17, 18. Now it's the position, and 30 degrees all the way down. So this is the flap surfaces. You see over here they keep extending right now, both sides the flaps, also the speed brakes over here, which also act as flight spoilers. Here you see the speed brakes are right here. This handle. So we have a few more things to see before going for flight management computer here. We have the engines indications, left and right engine over here. The flaps, the horizontal trim, stabilizer position here, the rudder trim, the outflow valves from the cabin pressurization system over here. You can set the takeoff gross weight of the aircraft, 357.4 thousand pounds total fuel on board. Fuel temperature right now -5. So you can set also a few more things: the standby display, the landing gear over here, up and down, retract and extend, alternate gear over here, lock override, the retract speed of the landing gear, rejected takeoff here, the auto brakes, rejected takeoff, or landing position. So in landing you set 1, 2 or 3, disarm and off. So I will show you a few more things, actually as many as we can, before going into flight. The overhead panel, so we'll set up the flight management computer now. I will input all the data of the aircraft for this flight, and includes the gross weight of takeoff, includes the empty weight plus the passenger plus the cargo plus the fuel on board, where the fuel is stored in the left and the right wing. In the center tank, how much we have: 30% in the left and the right wing, 10% in the center tank. The flight management computer is going to calculate automatically the center of gravity and the mean aerodynamic chord position for takeoff. That is 33% of the Mach of the mean aerodynamic chord position. As I told you, where the maximum aerodynamic lift occurs, also where the stall begins in flight for a given angle of attack. So you have to monitor the stall speed over here in the primary flight display. It has to be below the airspeed. So the airspeed has to be above the stall speed all the time. You will see the red and yellow indication of the stall. We need to be avoided. So we have how much fuel we have in the left and the right wing. In the center tank, 30% and 30% in the left and the right wing, 10% in the center. As we fly, we burn fuel, so the center of gravity is being recalculated every second from the flight management computer. That also sends information to the flight control computers, the autopilot flight director system panel, and the autothrottle. So we have all the navigation of the aircraft automated. You can see also we have in the flight management computer, I input all this data. I will calculate the horizontal trim stabilizer position, the horizontal elevator trim also for flying 4.25 degrees. We're gonna set it for takeoff. It's gonna give a pizza nose trim of the aircraft, pizza attitude for flying. We can trim also manually or automatically during the whole flight from takeoff, climb, cruises, and approach and landing. So I'll just show you how to do that. Also, we're gonna have the runway we're gonna use for takeoff: the Zurich International Airport, the Lszh, and runway 14. The runway length, the runway slope, the wind direction and speed, the barometric pressure, the density of the air, and the temperature of the air. We're gonna have also the flaps for takeoff, 15 degrees, the thrust commanded from the engines and the takeoff speeds. We're gonna have a pitch attitude of 9 degrees or less for takeoff rotation, also for landing. So this is gonna calculate the flight management computer, the takeoff speeds, V1, V-rotate, and V2. I'm gonna insert also the seats. The seats are the standard instrument parts, waypoints, and fixes that include horizontal and vertical navigation fixes, the initial climb of the aircraft to the cruise level, and altitude and airspeed constraints. We're gonna cruise to the cruise level at 25, 26, 27, 29, 30,000 feet above the sea level. We're gonna transverse through some waypoints. Then we're gonna have the top of descent back to the airport elevation, like 7 or 6,000 feet above the sea level. We're gonna have the stars, the southern terminal arrival waypoints and features that include horizontal vertical navigation features and altitude and airspeed constraints for the aircraft for the terminal approach and landing. For the long final and short final approach, we're gonna have also the ILS localizer, the instrument landing system. As I told you, the ILS localizer frequency is going to be tuned for this airport runway that transmits the radio frequency from the antennas threshold and is received from the onboard antennas receivers from the aircraft. So we're going to have the horizontal localizer, the vertical glide slope for horizontal alignment with the runway heading of 136 degrees for this runway 14, magnetic northbound heading of 136 degrees, and also the vertical glide slope. And we're going to be aligned for a flight path for landing. We're going to have a pitch attitude like 9 degrees or less for touchdown, flaps like 25 or 30 degrees, and an airspeed 150, 160 knots. Also the landing gear done. So you will see how we're going to be approach and landing. We're going to have a complete flight plan or flight path or route for this aircraft. So you'll see what we're gonna do right now. I'm gonna set the flight management computer over here. So go here in the control quadrant. You can see we have this displays. Also we have the mouse pad we use for controlling the displays here of the flight management computer. So you have also this view here of the aircraft. So you can see here we can select either mode, identity, position, performance, takeoff, approach, annunciate status, navigation data, flight plans, loaded, track control route, load plan, save plan. safe flight plan. So we have the identity is model 787-900 Boeing ZNX engines, Iraq cycle. So we have the position, the reference airport, Lszh, it's in Switzerland, Zurich International Airport. Runway 14, we're gonna set it later. So this gives it aligns the horizontal alignment of the aircraft with the magnetic north pole and geographic north pole and the GPS coordinates. So we have the performance here. We're gonna set the takeoff gross weight, the cruising altitude, and also the cost index and a few more data. So we have the route from origin here from Lszh airport back to Lszh airport, copy paste, and then we're gonna have runway 14 over here. We're gonna clear the discontinuity over here. So we have runway 14. As you can see, this is departure origin destination runway. I'm gonna set for takeoff. So we have departure and arrival over here. Set departure. We can select runways 10, 14, 16, 28, 32. So we select runway 14. The seats, these are the range for departure waypoints and fixes. Zurich to Alpha. So departure arrivals, we select here the arrivals. We can select one 16, 28, 34, ILS 14, ILS 16, next page, ILS 28, ILS 34, GLS 14, localizer 28, localizer 34. So we can select any approach, runway, ILS, instrument line system, trans, Amity, ILS 14, so Transnegria. So the star shot is the Negria. This are the terminal arrival waypoints and fixes. What I told you for the terminal approach, horizontal vertical navigation fixes, and alternate airspeed constraints. So we have now all the waypoints of the flight plan, the route legs. As you can see, it displays route legs in blue, and you can see all the route legs. We have created one waypoint after the other. The distance in nautical miles from takeoff as we climb from one waypoint to the other, the airspeed and the altitude and the and the heading change. So we have to cancel out discontinuity here. You can see the cruise over here. I'm gonna select the cruise level, descent, approach, and landing. So we go here in the initialize. So we select zero fuel weight over here. So we have the zero fuel weight for the aircraft. We can set here zero fuel weight, reserves 5% over here. So the fuel on board, zero fuel weight 322.7 thousand pounds plus fuel on board 34,200. We have gross weight 357,000 pounds. So we have the cruise altitude now 35,300 feet and the cost index 100%. It will give us the fuel freezing temperature over here, minus 37 degrees. You can see it's gonna freeze the fuel, so we have recirculate the fuel automatically when flying, so it will avoid freezing. It recirculates with the FAREX cruise center of gravity. Also here, step. Also we press execute now. Over here will activate with a purple active route with white and purple here. First waypoint. 2 nautical miles, 1900 alpha, TRO 96, 1 nautical miles, 250, 3290, then a few more, 5 nautical miles, Zui 05, 2 heading, 6 nautical miles, 300 knots, 6000 alpha. Next page, Negria, 26 nautical miles, with chains, we make a turn, 071, 302, 301 knots, flight level 22,200, motive, we make a right turn, 230 degrees, 11 nautical miles, 320, 11,800. Also we begin the descent here for the approach and landing. Amity 190 knots, 10,400, 6 nautical miles away, 9 nautical miles, Z, speed time, 108 knots, 7,000 alpha, Z8701, 6 nautical miles, 108 knots, 6,000 alpha. then TRA 290 degrees, 10 nautical miles, 180, 5000 alpha, 235 CI 146 nautical miles, 184,000 alpha. Then we turn left for the runway heading 5 nautical miles, 174,000 also. Then runway 148 nautical miles, 140 knots, 1430 feet. So this is the complete route from takeoff, climb, cruises and approach to landing. We have also to set the flaps for takeoff 15 degrees, center of gravity and trim 28.25 degrees, V1 128, V rotate 130, V takeoff 140 knots over here. So this is the takeoff rotation speed, gross weight and runway. So this is what we need to do. The legs are created, initialized. We have a few more alternate VNAV over here, progress, FMC communication, hold we can hold here when we fly, fix, you can set up fix, and navigation radio frequencies. So we go back in the cockpit. We are almost ready for takeoff. A few more things to see and said before making the engine start demonstration. So you will see now all the flight plan route here we can control using the mouse pad here. As you can see, we have the display here of the navigation, the airspeed, the altitude, barometric altitude, vertical rate of climb, descent. Also you can see the flight plan now created. So this is the route from takeoff, climb, cruises and approach and landing. The vertical also profile, how far above the ground we're gonna be flying, thousands of feet. You're gonna see the terrain around you and below the radar. Display the heading, ground speed, range 80 nautical miles. So maybe we're gonna change the range now. Already you will see a few more closer detail over here. The waypoints we have to fly through. From takeoff, climb, over here you can see the climb route, the vertical profile, the horizontal, the terrain also, the airports where they are located. So you can see also the runway. You can see the taxiway here in front of us, the runway we're gonna use for takeoff, and the other runway. Also the mountains in front of you, you will see. So this is the taxiway, the runway, other runway over here. So it's quite easy. It's like in the GPS you can see outside everything is identical in the display. Over here also the mountains, the terrain below you as you're flying. You can see with yellow and red. Also when you're gonna be flying, you will see the mountains, so you will have to fly above them if you have any. Also the horizontal, the center display also with the 360 degrees. You can see how far away we're gonna be flying here. Here you can see better view of the waypoints, the furthest away. Over here the Mativ Negria, over here Osnam. So it looks like kind of complex, but it's easy. You can see also further away, you'll see here is Germany, here is France, here is Switzerland, this airport name over here. So we go now in this display also, the review. You can see how close we can look over the aircraft, the detail, map setting over here, FIR airspace over here. You can select the other airport. So look further away, you will see one waypoint by the another. So this is from takeoff, the runway we're gonna use for climb, cruise over here, other airports. So we look closer now, how far away we're gonna be looking, and further. So this is all for the navigation purposes. We have also the air data computer over here in the overhead panel. It displays all GPS receivers, laser gyroscopes, magnetic north pole, pitot static and pitot dynamic for the airspeed, dynamic airspeed, and pitot static barometric altitude, vertical rate of climb, descent, laser gyroscopes, radio altitude, also angle of attack as we fly, temperature, barometric pressure here. So this is the air data computer, alignment of the aircraft. So I'm gonna show you now how we're gonna start the engine. So I'm gonna make an engine start demonstration. So you can see the engine is displayed here. We have the N1, which is low speed starter, sub low pressure compressor, and turbine turbo fan, which is engine the left and right. 19.8 maximum takeoff, 99.3 green, red, yellow limits, exhaust gas temperature 450 Celsius, and 268.5% which is a high speed starter, sub high pressure compressor, and turbine of the turbo fan, which is engine left and right. Fuel flow parents per 1000 kilograms, 1000 pounds, hold pressure, hold temperature, hold quantity, and the vibration of the N2 states of the engine. So we can have also the outflow air over here from cabin pressurization. I'm gonna make an engine start demonstration in a couple of minutes. So we use in the manual, you will see what happens, what it displays. So we have the FAREX to control the functions of the engine. The FAREX are the full authority digital electronic control computers, one installed per engine gearbox, dual channel redundancy, one channel phase, the other takes over, controls monitors, it displays all the engine data. I just showed you in the display in the multifunction display all the ACAS, engine indication alert system display. Also this can control monitor fuel flow, fuel metering unit, fuel heat exchange sensors. We have the fuel heat in flight. We need to recirculate it from the wing tanks and the center tank to the engines components to duct heat from the engines and heat up the fuel. Also we do the same for the lubricant and the oil is automatically controlled by the FAREX. Also engine starting inside down, exit failures. Also pressurizer from the left, from the 5th and 9th stage of the engines. High pressure compressor and starter stage, also from the front fan bypass air, which is admitted from the packs for cabin pressurization, weak engine RDIs, air conditioning ventilation, oxygen regulation in the cockpit and the cabin. Also for hydraulic fluid tanks pressurization. So when we move the flight controls around, you have the flight control computers, you have also the hydraulic tanks here which are pressurized, the landing gear, also the thrust reversers for the engine, parking brakes, nose, wheel steering. So you see the wings moving around. You have the hydraulic pressure from the engine's pressurization. Also the FAREX control as we climb the aircraft from the sea level all the way up to like 20, 30 or 40,000 feet above the sea level. As we climb higher, the pressure of the air becomes less. The pressure of the air, the density of the air and the oxygen become less than half than that of the sea level. Also the aircraft will be flying with an airspeed rate like 2 or 3 times faster than that of the sea level. Also the temperature of the air becomes freezing, minus 20, minus 30, minus 40, minus 50, minus 60 degrees below 0 Celsius. So we're gonna have a different fuel mixer request every second, which is adjusted automatically from the FAREX, because we have higher intake also of air from the front fans as we fly faster, and a thinner air. So it's a good thing to have the FAREX installed into your engines to do the fuel mixer also adjustment as we descend back to the sea level. So I'm gonna show you now the APU. Gonna start the APU to start the engines. We have the electric panel here. You can see the battery, ITZ, left and right engine driving contactors for the generators, 120, 200 volts, 400 Hz frequency, hydraulics over here, primary flight control computers over here, air data computer, flight control surfaces, towing power, FD door, passenger oxygen, window heat over here, rammer turbine. So the hydraulics we can turn off. You see what happens, the pumps over here in the fold. So this is the engine driving, primary demand. Back to the auto, we have the electric wing and engine RDIs over here, on or auto. We have also we have here the recorders, APU and cargo fire. We have electronic engine control for the engines, left and right, normal and alternate modes, auto start. For the engines, the fuel jettison, we can dump some fuel in flight, lose weight, select the nozzles, we will arm this. We have also the left and the right wing and the center tank, the crossfeed valve, the fuel system. So we can turn on the crossfeed. You can feed either engine with either palm or either tongue, or balance the fuel between the left and right wing, as you can see. So we have also the pressurizer, as I told you, from the engines and from the APU, air conditioning, ventilation, cabin pressurization. So we have the outflow valves here for climb descent. In the manual mode, the auto would need to do nothing. So one last thing left to see before going for takeoff, the systems display here. You can see what it displays. We have the hydraulics, the APUs running, oxygen and liquid cooling. So we have the electric here. You can see left and right ITZ controllers, IPUs running, the main battery and the battery voltage and barrage over here. So it's 100 to 200 volts for 100 Hz frequency. Hydraulics, where the hydraulic fluid goes, which system uses, primary demand, electric C1, C2, 5100 psi, left, right and center. Side of valves, fuel, left and right. Wing 11,000, center 11,000. We have total 33,500. Low and high pressure fuel valves left and right. Feed from the center tank right now. The APU is fed also from the left wing using the DC motor. The crossfeed valve is off, but we turn it on. You can feed either engine with either pump or either tank. Also, you can see the minimum fuel temperature over here. Below which the fuel will freeze in flight, minus 37 degrees. And the fuel temperature right now, so we recirculate automatically the fuel from the wind tanks to the engines using the FAREX control. We have the PAX pressurizer, left, right engine, APU, doors are closed, the cabin can be pressurized, the gear, the pressure of the tires and the temperature of the brakes over here, the nose wheel flight controls. So we use the flight controls here. We move around, you will see what it displays in the display, the wings, the tail of the aircraft also. The horizontal trim stabilizer, FS display, status, maintenance, circuit breakers again. Last thing to do, the checklist, normal menu before start, after takeoff, descent, approach, landing. So we go back to the navigation display. We turn off both engines right now, as you can see over here. Both engines, fuel control to the off. Turn on also the lighting. So we have only 1 minute for this. So going 9 to 5. So you can see both engines are off right now. You can see the hydraulics are turning off. So we need to restart over here the starter to the auto start position, automatic. So you see the yellow reconfiguration in the overhead. You can see also we have pressurizer from the APU right now. It's running into the engine, it's flowing to the compressors, to the engine starter, 30% and higher. We can hear here the now we can let the fuel left and right wing engine fuel control. So we have the auto start automatic, 30%. Auto start keeps rolling. 40%, 45, 46, 47, 48, 50, keeps rolling, 54. So we have the systems on, as you can see. So now we have running engines with green, both engines. So now we can go for takeoff. Flaps for takeoff here, parking brakes off, advance the thrust levers and go for the runway. We have the runway clearance from the air traffic control. So we align with the tiller. So align with the tiller over here, with the runway heading. So this is how to align with the runway heading over here. So we use takeoff thrust power over here, full takeoff. So we have 80 knots aligned with the center line again, using the rudder pedals. 100, 115, V1, we rotate slightly over here. So we have the rotation, positive rate of climb. Keep climbing, landing gear up. So you can see we're climbing over here. You can see we are just 2,300 feet above the ground, 2,400, but 4,000 feet above the sea. We climb with 4,500 feet per minute, 161 knots the airspeed. The stall speed here, the flaps limit, the wind direction and speed 170, and here is the ground, the terrain around you and below you. So you have to avoid the terrain as you fly. You can see the aircraft now is about 4,000 feet above the terrain below. So we have also the flight plan we need to follow. So we start the turn over here. Gonna begin in a while. You can see the runways here. We just take off over here. The lakes, the Switzerland lakes here, the Swiss Alps. So we start the turn. For following the flight plan. So keep climbing, as you can see. Also we're gonna set here the other side flight plan display. We can level off here. Stop the turn. You can see we can hence fly off the flight controls like this. There is no problem. The aircraft keeps flying its trajectory. Since it's a fly-by-wire aircraft, and we have 3 minutes right. We keep climbing 11,000. So maybe a few more knots in. And we have 13 more minutes for this flight. So this is after takeoff, the view of the cockpit over here. So you can see also the engines state here, the airspeed, the stall speed. We need to avoid the wind direction. The next waypoint we have to fly through. Autopilot flight director system panel. I hope you like the crescent, the moon over there, and the other aircraft, the Galaxy. The Italy with the Switzerland here, the Swiss Alps. The Germany, my homeland over here, by Munich and the lake, the France. The Galaxy. So this is the view of the Boeing. aircraft, Boeing 787, as we're flying here. So I'm gonna make a small turn. So we need to align here with the heading of the flight plan, as you can see. So we need to climb a bit faster. You can see the zoo is 2.4 nautical miles to the left of us, and we're gonna overshoot the zoo. We're gonna fly to the next waypoint over here, as you can see, the Negria over here. So here we are, we're gonna start the turn now. We see the galaxy over here, the Switzerland, the beautiful lake, the Germany, Bayern Munich and France. So we're gonna start the turn now. We're going back to the airport. So we can turn with the hands off manually without the autopilot, as you can see. There is no problem. You can level off just right away and you can start the turn again. So it's quite easy to control the aircraft. Also use some right rudder as turning. So here's the turn over the Bayern Munich, Germany, here is Switzerland. So this is the beautiful view, the France. So you can level off here. So here we are gonna have now the chemtrails, as you can see. Chemtrails and contrails are the frozen vapors from the aircraft tail. So we leave behind the Germany, the lake over here, and we're going the France on this side. So beautiful view, the lakes, the France, the Switzerland. So we're gonna start the descent now. So we're gonna make a small turn and start the descent, and we have like 6 more minutes for approach and landing over here. So we start the descent now, as you can see. So we have 6 more minutes for descent, approach and landing over here. I'm gonna increase also the airspeed as we descend. So this is a beautiful view of the cockpit as we are descending. And we have 5 more minutes for approach and landing over here. Leveling off, throttle used to the idle position here as we are descending. Need 4 more minutes for descent and approach here. So we make another turn over here for approach and landing. We need to align out the runway heading as we turn. So we use a little bit left rudder for this turn. So we have 3 more minutes for approach and landing. As you can see, we have to follow the waypoints here for the approach and landing to the runway. So we're gonna use some flaps, and we are in the final approach and landing over here along with the runway. So we align with the runway. We have some side wing over here, as you can see, We need to combat the side wind to align with the runway center line. Also add some airspeed over here. We have about 1 minute left for approach and landing. So we need to align with the runway. We have about 1 more minute for the video record to end. Also you can see the Lszh localizer here, the glide slope and the localizer, the information as we are approaching for landing. So we align over here. We're gonna flare in a couple of minutes, couple of seconds actually. So we are approaching for the touchdown, align with the center line, combat side wind and wind gusts. And here is the flare the aircraft, touchdown, beautiful touchdown, parking brakes, and thrust reverse, idle and thrust reverse over here. So we're slowing down the aircraft and align with the rudder pedals, as you can see. So we made a very beautiful landing over here. As you can see, all the landing gear, the nose wheel is perfectly safe of the aircraft, and we keep slowing.